Hello, this is Mr. Hansen. I'm joining you and I'm looking at two different quadratic equations, quadratic functions. And I want to work through each one with you. In the past, we looked at a graph of a quadratic function and learned some things, but this time we're looking at some equations. So the first equation has to do with the area of a rectangle. You'll notice that I've labeled the long side of the rectangle x and the short side x minus 1, so it's 1 unit longer than or 1 unit shorter than the long side. And then over here we have x times x minus 1. That's length times width. That gives you the area. And you can also distribute that x out if you want to, so it's x squared minus x. Both of these expressions mean the same thing. And I'm going to plug in some numbers for x. So f at 2, when x is 2, 2 squared, that's 4 minus 2 is 2. F at 3, 3 squared minus 3 is 6. That's 9 minus 3 is 6. 4 squared, that's 16 minus 4 is 12. And 5 squared, that's 25 minus 5 is 20. So here we have some points. Let's just go ahead and plot them. 2, 2, 3, 6, 4, 12, and 5, 20. So at this point, after looking at those points, maybe you're thinking, okay, it's increasing a little more each time. It's possible that it could be an exponential function because we've studied those, how they increase. But maybe it's something else. So let's plug in a few more points just to get a better idea of what we're looking at. Now the domain starts at 1. You have to have numbers bigger than 1 or else you're not going to have a width here. But we're going to plug some numbers into the model anyway just to see what the equation gives us. So let's plug in 1. 1 squared minus 1 is 0. And I'll do this in a different color. So that technically wouldn't work in this context, but we're just going to kind of use it. Now we plug in a 0. 0 squared minus 0 is also 0. So right there. And let's plug in negative 1. So negative 1 squared, that's 1. Minus negative 1, that's going to be 2. So negative 1, 2 right here. And let's plug in negative 2, so that's 4 squared. Or negative 2 squared is 4. Minus negative 2, we're going to be up to 6 right there. And maybe you're starting to see some symmetry. At negative 3, we'll probably be at 12, and then at negative 4 will be at 12, and then at negative 5 probably be at 20, like that. So it's definitely not an exponential function. It's not nearing an asymptote or anything like that, but it's kind of going down, it's decreasing, and then it's going back up, and maybe you're wondering if where the minimum is. It's probably right between those two red dots, right about there. That's where the minimum would be, at 0.5 somewhere. So let's just talk a little bit about this function. First of all, it makes a U shape. So we decrease, and then from there we kind of increase, and it makes a U shape. We could figure out the domain and range of the graph. The domain would be all real numbers for the graph, and the range would be y has to be bigger than negative 0.5. We could also figure out the domain and range for the context. The domain for the context would be you have to plug in a number bigger than 1, so x has to be bigger than 1. And the range would be when I plug in 1 for x, I get 0. So range is y has to be greater than 0, and it can get really large. Okay, and the big thing that I wanted to point out here is that we have a decrease, then an increase. So what's going on is we have a minimum right here. This point right here is called a minimum because we stopped decreasing and then we started increasing. And so what is it about this equation up here that makes it a minimum? As long as you have a positive right there for the x squared, it's always going to be a minimum. It's always going to be U-shaped. Now in a minute we're going to look at a negative, and it's going to be n-shaped. So that's kind of the big idea. It flips things over. The other thing about this actual equation is if you have a quadratic equation, it'll always be x squared. The leading degree will be squared. So there won't be an x cubed or x to the fourth, but there will be an x squared, and then there might be an x to the first or a number. But that makes it quadratic. So hopefully this is helping you get an idea for how quadratic equations work. Nice thing about this function, you could plug in any number at this point. You could plug in 10. 10 squared is 100 minus 10, you'd have 90. And so again, the nice thing about equations as functions is that you can plug in any number and get out an output. A graph, a little bit more work to it, and sometimes they're not as accurate. All right, let's look at the next one. This time a man is cliff jumping. He's jumping from 400 feet high, and he kind of just walks off the edge, and he lets gravity take him right down to, hopefully there's a nice pool at the bottom there, nice pool of cold water. And so look at this equation. It's saying negative 16 times my number of seconds squared plus 400. This first term of the equation is the force of gravity. So for gravity, you lose 16 feet per second squared, or you get 16 feet per second squared closer to the Earth. And then this 400 is the y-intercept. That's how high he is off the from the water below. So let's just plug in some numbers there. If you have 0, that's pretty easy. It's 400. If you have 1, 1 squared is 1 times negative 16 is negative 16, so it's at 384. Now you might already notice on this table we are decreasing this time. Let's keep going though, and then we'll figure out what's going on here. So at 2, we get 336 feet. And at 3, we get 256 feet. And at 4, we get 144 feet. And at 5, we get 0 feet. So I had those numbers already worked out, but if you plugged 5 in up here, 25 times negative 16, and subtract that from 400, that's how you got the 0. So let's plug in these points. You got this one here. At 1, we're at 384 right there. At 2, we're at 336 right here. At 3, we're at 256. At 4, we're at 144. And then at 5, we're at 0. So it kind of goes like this. And really, that's the domain for the context of the function. We're just going from 0 to 5. After that, and you've already hit the water, it doesn't matter. And this is time, by the way, this is time in seconds. And this is height. So after 5 seconds, you've hit the water. So it looks like half of a quadratic function. What do you suppose is going to happen if we put in some negative numbers? For example, let's put in negative 1. So negative 1 times negative 1 is 1, times negative 16 is negative 16 plus 400. So at negative 1, we're at 384 right there. And at negative 2, we'll be at 336 right about there. And at 3, we'll be at 256 right about there. And at 4, we'll be at 144 right about there. And at 5, we'll be at 0. So let's do this in red. You can kind of see something like that. And so the red portion, again, is not part of the domain. But if you were to plug numbers in for this function, you could kind of see that. Okay, so the question here is, this point, it's no longer a minimum, it's a maximum. And so we're increasing and then decreasing along this this exponential function here. So let's look at the equation. The negative 16 that we're multiplying by x squared is what's turning this over. That's what's making it an N shape instead of a U shape. And then of course the 400 was the y-intercept. Just a couple of other things to note. If we looked at the table, it's kind of interesting. With the linear equations, we'd go 6 minus 2, that's 4, and 12 minus 6, that's 6, and 20 minus 12, that's 8, and 90 minus 20, let's not do that one. 20 minus 12, that's 8. So 4, 6, 8. And then we could go 8 minus 6 is 2, and 6 minus 4 is 2. So quadratic functions have a common second difference. Linear functions had a common first difference, and quadratic functions have a common second difference. Let's see if it works for this one here. 384 minus 400 is negative 16. 336 minus 384 is negative 48. 256 minus 36 is 3 minus 5 is 8. And negative 80. And let's just go from there. So 48 minus 16 is going to be 32. And we're subtracting 32. And from 48 to 80 is also subtracting 32. So there you have it. It's a second difference. Okay. Big idea out of this was that you recognize maximums and minimums, and that you start to feel comfortable with quadratic functions as equations. So an equation here, an equation here. Remember, they have the x squared in them. That's kind of the identifying feature of what makes them quadratic. Thank you very much.